The electrical chapters of the International Residential Code are based upon the 2017 National Electric Code, published by the National Fire Protection Association. The IRC provisions cover electrical installations normally occurring in the construction of 1- and 2-family dwellings and townhouses. This does not prevent the use of other wiring methods and materials that conform to the NEC requirements. Residential service loads shall be computed in accordance with the code. Services over 400 amps will require a design professional's review. A grounding electrode system is required at each structure that's served. Each electrode specified in section E3608 shall be bonded together to form the grounding electrode system. A minimum of 2 grounding electrodes is now required and shall not be less than 6 feet apart. During the electrical roughing inspection, the inspector will be looking for some of the following items. The panel box is to be in place. Service entrance wiring must be run. The wiring must be run to all locations. Unless the meter base and the service panel are located back to back or next to adjacent stud cavity, a 4-wire system with an exterior service disconnect is required. The sub-panel must isolate neutrals from the grounds. Reference the National Electric Code's Article 230.70 and 230.91. The panel box location must meet the required clearances, 36-inch width and 36-inch depth, to a height that's 6 feet 6 inches, and cannot be located in bathrooms, clothes closets, or over the steps of a stairway. During the electrical rough-in stage, the inspector will be looking for as many of the following as he can. Some of these items will have to be confirmed at the final. A 4-wire connection is required for stoves and dryers. Receptacle spacing on walls shall not be more than 12 feet apart, within 6 feet of a door, and on any wall over 2 feet in length. Please reference also E3901.2.1 for the complete listing. A minimum 2 20-amp circuits are required in the kitchen, 1 in the laundry and 1 in the bathroom. All must be number 12 wire. Kitchen countertop receptacle spacing is required in E3901.4. Wiring shall be protected from abrasion and from physical abuse. Holes closer than 1.25 inches from the edge of the member shall be protected with nail guards. Bond all metal water pipes. Bond each portion of a gas piping system that is likely to become energized. The 6 and 12-foot rule basically is that wall receptacles serve the spaces for 6 feet on each side of a receptacle. Therefore, the maximum spacing between wall receptacles is 12 feet. We will get into more detail concerning outlets located in kitchens later in the program, but one thing that I did want to point out is that in the kitchen areas, wall countertop receptacles serve a space of 2 feet on each side of the outlet. Therefore, maximum spacing between receptacles on the same countertop space is 4 feet. Edge of the drilled hole here is 1.25 inches or less. Therefore, they require a nail plate that should be a 16-inch thick that needs to cover the width of the area. One word of caution, we have recently heard that there are some what I call bootleg nail guards out there that are less than 1/16 of an inch thick, and they're being sold at some of the large box stores. Concerning support of NM or Romex cable, typically 12 inches from every box, 4.5-inch intervals along the length. 314.17c gives an exception that a single gang box with no clamps, the smash out for the NM box cable has to be at least 1/4 inch inside the box and stapled 8 inches from the box. During the roughing inspection, the inspector may observe that the provisions for supplying power to an island in the kitchen area has improperly been applied. A common mistake is for the installer to install a non-metallic sheath cable type NM or Romex in a PVC or other raceway to the kitchen island location. A review of 300.5b and the list item number 6 should be referenced for installations in the earth or under a building. The problem is that type NM cable is not listed for a wet location, and any conduit located under a slab is considered a wet location. Continuing with our electrical roughing inspection, Use UL listed fixtures as designed or tested. Luminaires and closed closets must meet the required clearances from the fixture to the nearest point of a storage space. Where installed in or attached to a building or structure, metal piping systems, including gas piping, capable of being energized, shall be bonded to the service equipment enclosure or one or more of the grounding electrodes used. And an inter-system bonding termination is required for communication system cables. Reference IRC Section E3609.3. The inspector will be checking box fill, and during the inspection process, please make sure your electricians are aware of this and they are well versed in the calculation methods. Quite often caught on the final inspection is the location of boxes and the finished walls. Flush mounted, surface mounted, what's the finish? You've got to learn what it is. So if you have non-combustible tile or gypsum, you're allowed, the box can terminate 1/4 inch from the face of the finished wall. But for combustible wood framing or anything like that, a fabric or a wallpaper, then it's going to have to be flush with the system. The use of goof rings, and that's what we call them, should be discouraged, although it is often used. The biggest concern we typically see is kitchen countertops when they apply the 1/4 inch or sometimes greater tile that gets the box recessed. Again, an extension ring that's approved for its use should be used at that point. Smoke and carbon monoxide detector wiring must be installed at the time of the rough-in inspection. During the rough-in inspection, the inspector will do their best to look for the locations and make sure locations are in compliance with the code. However, it must be stated that final determination for placement of smoke and carbon monoxide detectors occurs at the time of the final inspection. Therefore, it would be in the contractor's, both the builder and the electrical contractor's best interest to review code compliance for location of smoke and carbon monoxide detectors and their rough-ins. A few key notes to review at the rough-in stage of the inspection. Wall-mounted alarms must not be more than 12 inches from the adjoining ceiling surface. Avoid placing alarms less than 3 feet from supply registers of a forced air heating or cooling system, and do not place alarms in the direct airflow of registers. Avoid placing alarms within 3 feet horizontally from doors to bathrooms containing a bathtub or a shower. Do not place alarms in spaces where temperatures may be above or below the alarm's operating temperature range. Do not place alarms within 3 feet of the blades of a ceiling fan. Alarms in peaked or sloped ceilings must be within 3 feet of the peak measured horizontally, but not in the highest 4 inches of the ceiling measured vertically. Avoid placing alarms in dead air spaces. At the time of the rough-in inspection, the electrical inspector will not know what device is going to be installed. So here are a few key things concerning smoke alarms near cooking appliances that the builder and the electrical contractor should review. A. Photoelectric smoke alarms must not be less than 6 feet from a permanent cooking appliance. B. Ionization smoke alarms with an alarm silencing switch must not be less than 10 feet from a permanent cooking appliance. And C. Ionization smoke alarms without an alarm silencing switch must not be less than 20 feet from a permanent cooking appliance. Concerning carbon monoxide alarm locations, do not place alarms directly above or beside fuel burning appliances. Do not place alarms in direct sunlight. Do not place alarms in low areas where children can reach. Do not place alarms behind curtains or any structure that might prevent carbon monoxide from reaching the sensor. So let's review ceiling outlet boxes in a couple of instances. First, let's go to E3905.6.2. Ceiling outlet boxes used exclusively for lighting shall be capable of supporting a luminaire weighing up to 50 pounds. A luminaire that weighs more than 50 pounds shall be supported independently of the outlet box, unless the outlet box is listed and marked for the maximum weight to be supported. To expand, we're going to also go to E3905.8. E3905.8 covers that when a ceiling outlet box is wired for a future ceiling fan, the box must be listed for the support of that ceiling fan. In new home construction, ceiling fans often are installed in bedrooms and other living spaces of the dwelling unit. Typically, 2 switches are installed, one to control the fan operation and one to control the light. Many times, the ceiling outlet installation is wired for a future ceiling fan to be controlled with a separate switch, but only the ceiling light is installed at the rough end. The spare ungrounded conductor from the second switch is capped at the ceiling outlet box for future use. This installation provides options for future homeowners to choose the location and style of any ceiling fan that they may wish to install, while still providing the convenience of separate switching of the fan and the accompanying light kit. However, the initial installation may include a box that is listed to support luminaires only, and homeowners may not know that ceiling fans require outlet boxes or support systems that are designed specifically for ceiling fans. To address this, the code now requires the ceiling outlet box or outlet box system to be listed for supporting ceiling fans when a spare switch-controlled ungrounded conductor is provided to the ceiling outlet. The new text intends to add a level of safety to the home and prevent injury due to the falling ceiling fans. During the rough-in inspection, the inspector may observe multiple conductors protruding from an outlet box in the bedrooms. They may also see that its switching controls at least 2 functions. This will trigger these questions, and it is wise to be prepared for them. To expand on this subject, while the 2020 NEC has not been adopted in my jurisdiction, we do look for that to happen very soon, as well as the 2021 IRC series. The 2020 NEC adds language concerning ceiling fan outlet boxes specific to the information we just provided. During the electrical rough-in inspection, the inspector may observe pancake boxes such as the one pictured here. This is a UL-approved device when installed per its listing. Pancake boxes have a capacity of 6 cubic inches. Circled in this photograph is the 6 cubic inch marking. One 14-2 wire requires a minimum 6 cubic inch capacity. Anything more than that, it would be a violation of the code. 12-2, to demonstrate my point, requires a 6.7 cubic inch capacity, so technically you cannot have 12-2 in a pancake box. The process, policies, and procedures for the final power release varies by jurisdiction. Therefore, check with your local jurisdictions for their requirements. Typically, what we see in the Southeast is that all conductors should be protected, that the panels, if not made up, at least 2 breakers are added, and at least one of those supplying a GFCI outlet, and that be completely installed, and everything be secured from any accidental contact. But again, check with your local jurisdiction. Some of the key items that the inspector will be looking at during either the power release or the final electrical, or some version thereof, include the following: that all panels to have the proper working clearances, that a main bonding jumper is needed in most main disconnect panels unless otherwise integrated, that equipment grounds and neutrals are to be isolated from one another in sub-panels, close all unused openings. Service conductors are to be sized properly and identified with the correct insulation type or electrical tape. All service and feeder conductors are to be terminated and torqued per specifications. It is recommended that a corrosion inhibitor be applied to all conductor terminations. System grounding. The premises wiring system shall be grounded at the service with a grounding electrode conductor connected to a grounding electrode system as required by this code. All electrodes specified that are present at each building or structure served shall be bonded together to form the grounding electrode system. Rod and pipe electrodes not less than 8 feet in length and consisting of the following materials shall be considered as a grounding electrode. Number 1. Grounding electrodes of pipe or conduit shall not be smaller than trade size 3/4 inch, and where of iron or steel shall have the outer surface galvanized or otherwise metal coated for corrosion protection. Number 2. Rod type grounding electrodes of stainless steel and copper or zinc coated steel shall not be less than 5/8 inch thick in diameter unless specifically listed. The rod and pipe electrodes shall be installed such that at least 8 feet of the length is in contact with the soil. They shall be driven to a depth of not less than 8 feet, except that where rock bottom is encountered, electrodes shall be driven at an oblique angle not to exceed 45 degrees from the vertical, or shall be buried in a trench that is at least 30 inches deep. The upper end of the electrode shall be flush with or below ground level, except where the above ground end and the grounding electrode conductor attachments are protected against physical damage. Each type of ground rod, copper coated, zinc coated, or stainless steel, has varying finished diameter tolerances. Depending on the conductor wire size, a variance in diameter may result in a clamp with a bolt that is not long enough, or so it may not compress the ground conductor adequately. There have also been cases where a listed clamp was large enough to fit over a full-size galvanized ground rod, but a stranded conductor of the largest size listed on the clamp could not be clamped properly, which resulted in an inadequate and therefore unsafe ground. In the IRC and NEC Article 250.70, the grounding or bonding conductor shall be connected to the grounding electrode by exothermic welding, listed lugs, listed pressure connectors, listed clamps, or other listed means. Connections, depending on solder, shall not be used. Ground clamps shall be listed for the materials of the grounding electrode and the grounding electrode conductor, and where used on pipe, rod, or other buried electrodes, shall also be listed for direct soil burial or concrete encasement. Not more than one conductor shall be connected to the grounding electrode by a single clamp or fitting, unless the clamp or fitting is listed for multiple conductors. Standards seen in residential construction include the acorn clamp and the brass tooth clamp. The acorn clamp is listed for ground contact, whereas the brass tooth clamp is typically used for pipe connections and is not typically listed for use to be in contact with ground, soil, or concrete. Clamps must be installed per their listing. Along with the listing mark, there's a reference, usually stamped on the side of an acorn clip. These references will give you identification if it's copper, which is Cu, galvanized, GALV, or stainless steel, SS. So in this case, what we're going to see in these photographs, we see here that we have a Cu, GALV, and stainless steel marking on this clamp. Also on this clamp. This clamp is for 1/2 inch rebar. This would be like for doing my concrete encased electrode. 1/2 inch to 5/8 is what the connection is, and this 1/2 inch rebar. So it's up to the inspector to make the determination concerning the listing and the use of the clamps. For bonding of other systems, typically telephone, satellite, and cable television systems, to the building's grounding system, the code requires installation of an intersystem bonding termination, a device that provides a means for connecting grounding and bonding conductors of communication systems near the building service equipment. The bonding termination must be accessible and must have provisions for connection of at least 3 bonding conductors. A set of listed terminals mounted directly to the meter cabinet satisfies these requirements and may be the most common installation. Other approved methods for intersystem bonding include the installation of a bonding bar near the service enclosure, meter cabinet, or service raceway. Depending on your jurisdiction, some require this inter-system bonding termination bar to be installed at the time of power release, or it may be confirmed at the time of the electrical final inspection. Okay, you've made it this far. Thank you for your attention. I ask please that you buy me a cup of coffee, like and subscribe on YouTube so that we can continue these videos for other folks. And if you'd like a copy of the residential inspection checklist, or maybe a little quiz that we have written up based on the residential code, you can get that by sending me an email to the email address you see here, which is dolesmichael@gmail.com. So please like, subscribe, support this work. If you would like to have Doles Enterprises come out and do a presentation in person to your group, we can certainly discuss that. Just depends on logistics and a few other things, but we'll do whatever we can. So visit our other videos, and we appreciate everything that you're doing, and we appreciate your attention. Mike Doles again. Just wanted to let you know that we're concluding this session, and ask you to please go to the next session and take your time. Please like and subscribe to this YouTube channel. This is how we're able to offer this free. And also anything you can do to buy me a cup of coffee or any other way you can do to help support this, we certainly do appreciate it. So just proceed to the next session. Take it at your own pace. Don't become overwhelmed. You're not going to know it all to begin with if you're just now starting out in this profession as a building inspector.